Today I'll teach you about the operators in Python. So what is an operator? So operators are basically used to do some operations on variables and values. So I can write like operators are used to perform operations on variables. That is, we can call it as operands and values. Okay. Now suppose I want to do some addition, some multiplication, some division. Okay, and we do have the other types of operators. So generally we work on variables, or we can directly work on the values. And the variables are called as operands here when you do the mathematical expressions. Now what type of operators are available, we'll see. Now coming to the types of operators in Python. Now one is arithmetic operator. Then second one, we have assignment operators. Third one, comparison, or we call it as relational operators. Then we can have logical operators. Then we have identity operators. Then we can go for membership operators. And then we can go for bitwise operators. Now these are the operators available in Python. Now I'll see the first one. We'll see the first one. That is the arithmetic operators. Okay, now what all comes under arithmetic operators? We have plus for addition. Then we have minus for subtraction. Then we have into, that is multiplication. Then we have a forward slash for division. Then we have also that is modulus. Then we have that is exponential. I just put a comma for segregation. Exponential. Exponential. Then we have forward slash 2, that is floor division. Okay, now these are the operators what we have for the arithmetic operators. Okay, now we'll see the example of this. If I take x equal to some 5, y equal to some 6, I will take x equal to some 15. Now I want to print x plus y Okay, this is for addition. Then I go for print x minus y, subtraction, print x into y, multiplication, print x mod y, division, print. So it's not mod, it's a slash for division. Okay, x mod y now. Now this is for modulus, then print x into y. This is for exponentiation. Then print x two forward slashes y. Now this is for floor division. Okay, we'll see the output. What is for this? Okay, maybe I'll just take 5 and 3. Okay, now just run this, and here you are getting 5 plus 3 8, 5 minus 3 2, then 5 and 3 15, then division you are getting, then you are getting the modulus, the remainder is 2, and 5 to the power of 3 125, and the floor division is 1. Now this one get removed. Okay, when you go for the floor division, right? So we have done addition, subtraction, multiplication, division, modular, exponential, that is power of 5 power 3, 5 into 5 into 5. The next floor division y, where it is going to wind up to the whole number. Okay, so this one is removed and only you are getting the 1. For division you are getting the complete decimal value. Okay, so this is for addition. Now we go for the next one, assignment operators, the second one. Okay, now in this assignment operators, generally we put the equal to, that is assignment, then we have plus equal to, then we have minus equal to, then we have into equal to, then division equal to, here I'll put division equal to, then mod equal to, then the floor division equal to, then we have and equal to, then not equal to, then exclusive or equal to, then we have right shift, bitwise right shift equal to, bitwise left shift equal to. Okay, then we have colon equal to. Now these are all the assignment operators. Okay, now we'll see the example for this. Now I can take like something called x equal to some 6. Then I can write x plus equal to some 3 or 4. Then if I go for print of x value, then you can see what happens. Now here it is printing 10 because 6 is already there in x. Now plus 4, you're adding 6 plus 4, 10. Okay. Okay, now we'll check for next one. X minus equal to 4. Then print of x value. You got 6. Then x into equal to 4. Then print x value. You got 6 into 4, 24. Then x divide equal to 4. Then print. That means whatever the value has been there, the final result will be storing in x. So print of x. Then you got 6. Then x modulo equal to 4. Then print of x. We got 2 because 6 mod 4 remainder is 2. Then x floor division. Okay, so maybe the x need to be increased. So I have just changed the value of x. So maybe some 24 I'm given. So x floor division of equal to 4. Print of x. Then you can see again you got 624. Floor division of 4 is 6. Then bitwise equal to x and equal to 4. Print of x. So you get 4. But this is a bitwise binary number you need to go for, and you need to do the AND operation. Similarly, x or equal to 4. Print of x. Then you can see again you got 4. The next exclusive OR will check exclusive OR equal to 4. Print of x. Then you got 0 here. Exclusive OR. We'll see the operation when we go for the bitwise operators. Okay. Then we have similarly right shift and left shift. So I can go for x. Right shift equal to 2. Then print of x. So we'll see in bitwise operators how we are going to get this. Left shift of 4. Print of x. Still you're getting 0. Then x colon equal to 3. 4. Print of x. So you get the same print of x. Correct syntax. Okay. But x colon equal to 4. Okay, now you're getting that 4. Okay. So these are few assignment operators. Okay. Now this bitwise and or we will see that this is or. Okay, not or. Okay. Now coming to the next one, third category, we have comparison operators. Comparison. Okay. Now here we have less than, greater than equal to. Okay. So here we can write like double equal to is equal to, then here not equal to, then greater than, then less than equal to, greater than equal to. Now these are the relational operators. Now where your answer will be in true or false. Okay, so you can write here answers will be in true or false. Now if I take x equal to some 6 and y equal to some 3, and I want to perform like print x double equal to y, just will check the answer how it works. So you can see it is false because 6 is not equal to 3, right? Okay, I'll just write print x not equal to 3, then it's true. Fine. Print x greater than 3. So 6 is greater than 3. Here I need to write y already because y we have stored, right? Then just run. So it's true here because 6 is greater than 3. So print x less than y. It should be false because c is less than 3. It's false, right? You get false. Then print x less than equal to y. You get false. Similarly, print x greater than equal to y. You need to get true. 6 is greater than 3. So you got true. So all the comparison operator equal to, not equal to, greater than, less than equal, greater than equal to, all are comparison or relational operators. We will get the answer in only true or false value. You can see this one. Okay. So basically we use this in conditional statements. Okay. Right. That is the third one. Now coming to the fourth one, logical operators. Coming to the logical operators, we have 3: and, or, not. So here I make this one as well. We have and, or. So 3 things. So if I write and, so here I can write description like returns true, if both statements, that means more than one condition we need to use here. So both the statements are true. When you go for or, returns true if one of the statements are true. Either one is true, then obviously we'll get the answer. Then not, reverse the result. Okay, it reverses the result and returns false if the result is true. Now this is the thing what happens when you go for logical operators. So we'll see the example. Like if I take x equal to some 7, I'll write like print x is greater than 3 and x is less than 8. Now this is the condition what I'm trying to. 7 is greater than 3 and 7 is less than 8. If both the conditions are true, I need to get the answer as true. So you get the answer as true. Okay. Now the same thing, if I go for or, I'll just copy this. I'll put here. I'll put or. That means either of the condition is true, then your answer will be true. So here 7 is greater than 3, or else I'll take it's a 2. Okay, 2 is greater than false, but 2 is less than 8 true. So you need to get the answer as true. So you can see this condition is matching, but this condition is failed, but still you get true. Okay, if I use and here, you will get false. Okay, so either one condition is true, your answer is true when you go for or, right? Then we have not. I'll take the same example. So I just put here not. So actually you got here true, right? But I'm writing not means you need to get the reverse result. So it will return the result as false. So just click this. So you got the result as false because we have operated the negation not. If you get true here, it will make false. Okay. Suppose if I write or here, okay, still it is false because 7 is less than 8. The condition is true, right? Okay. So once you get the result here true, it returns false. And if you get the false here, it will return true, right? Then, so this is for the logical operators. Then next one, we go for the identity operators. Identity. The identity operators are basically used to compare. So just I'll write here the identity operators are used to compare the objects. Not if they are equal. So I'm not checking the value. Okay, but if they are actually the same object with the same memory location. Okay, so I'm not checking the value. I'm trying to check whether that belongs to the same object and with the same memory location or not. So here in these identity operators, we have two operators. One is. Now it returns true if both variables are of the same object. Okay, of the same object. I have is not also. Is not. Now here it returns true if both variables are not of the same object. Okay, so I'm trying to check whether it belongs to the same object or not. I'm not trying to check the values. So we'll take the first one. I'll just go with an example. I'll take some a equal to some xyz. I'm taking some string and some pqr. Okay, then I'm taking some b equal to same xyz and pqr. Then c equal to I'm writing a. Okay, now if I take like print a is c, print a is c, just will check what is the answer. You are getting true because a and c are holding the same memory location and the same object. But when you go for, I'll write like print b is c. Now returning false. because B memory location is different and A memory location is different, so they are not belong to the same object. So since the values are same, but still the object, the memory address of A is different, which is initialized to C. So A and C is holding same memory location, you're getting true. But here B is holding different memory location, A is holding different memory location, and that is A and C is equal. So C address is different, B memory address is different. So it is returning false. But the values are same. So here we are not comparing the value. We are comparing only the object. Suppose if I write the same thing, just I'll copy this. I'll write is not. It need to return false for me because A and C are same object, right? So it's returning false. Okay, if I write this one, it will return true. B is not C. Yes, correct only, no? It will return true. So it is returning true. Okay, so here when you go for is and is not, generally we need to check the object is same or not. That is, it is holding the same memory address or not. Okay, so this is for the identity operators. Then we go for Python membership operators. So that is the sixth one. Okay, now in this, now these operators are used to test if the sequence is presented in an object. That means I need to just verify whether the particular element is available in that particular sequence or not. So it could be list or it could be tuple. So we have in and not in operators, in and not in. So two are there. One is in. So it returns true if a sequence with the specified value is present in the object. Then second one, not in, returns true if a sequence with the specified value is not present in the object. Oh, okay, so we'll see an example for this. Okay, if I'm taking something called some d equal to, I'm taking a list again, like I'm writing x1, x2, x3. So there are three elements what I'm taking. Okay, x3. Now I need to just check. So I'll print like x2 in d. Okay, like x2 is available in d or not, I'm going to check. So my expected answer is true. We'll see. True. Okay. If suppose I'll just copy this, I'll give a different value like x4. x4 in d, it's not available, right? Just click this, false. If I write here not in, x2 is available, right? But I'm trying to check it is not in means it is false. Okay. Here I'll write x4 and I'll make not in. It need to return true because x4 is not available in this particular list, the above list. Okay, you're getting true. So in this way, you need to cross verify whether the element is available in a particular sequence. Sequence could be a list, a dictionary, the tuple. Okay, so now these are all the sequences. Okay, So just to check whether the particular element is available or not. Okay. Now that has been called as a membership operators. Now coming to the next one, we have bitwise operator. Bitwise. Okay. Now in the bitwise operator, now basically these are used to compare binary numbers. Okay, like zeros and ones. Okay, now coming to the operators, we have the operators like ampersand, which is nothing but AND operator. Then we have a pipeline symbol for OR operator. Then we have exclusive OR. This one is for XOR operator. Then we have negation for NOT operator. Then we have two less than means zero fill left shift operator. Zero fill left shift operator. Then you have two greater than symbols. Okay, we call it as zero fill right shift. Okay, operator. Right now, these are the six which comes under the bitwise. I'll see one by one. If I go for simple, if I go for print some six and operator. Okay, three. Now just see the answer. Now here you are getting two. Now how come you are getting two is when you go for the AND operator, we need to see that both the values need to be set to 1. So here if you want, I'll write the description also. When you go for the first one, that is A and D. Okay. Now for this, sets each bit to 1 if both bits are 1. Okay. Now coming to the next one. This is a pipeline symbol. Now that is for OR. Okay. Sets each bit to 1 if one of the two bits is 1. Okay, so either bit is 1, then your answer is 1. But one for AND, both the bits need to be 1. Then when you go for exclusive OR, we call it as XOR. Okay, now here sets each bit to 1 if only one of two bits is 1. That means both the bits need to be 1, then it will be 1. If one bit is 0 and one bit is 1, then it is becomes 0. Then we have negation. We have negation, that is not. Now here inverts all the bits. Inverts means reverse. Inverts all the bits. That means 0 will become 1, 1 will become 0. Then we have left shift. That is a left shift 0 fill left shift. Okay. Now for this, shift left by That means shift left bits by pushing zeros, in from the right, and let the leftmost bits are removed. Okay, we'll see at the time of demonstration. I'll show what it is. Then we have right shift. So I can say 0 fill right shift. Okay, then here shift right bits by pushing copies of the leftmost bit in from left, and let the rightmost bits are removed. Okay, now this is the expression for all. Now we have seen 6 and 3. So when you go for the 6 and 3, when you form a binary number, okay, if suppose I'll write for 6, when you convert into binary, it is like so totally 16 bits. 1 2 3 4 5 6 7 8 9 10 11 12 13 and 110. Now 2 power 0, this one is 2 power 0, 2 power 1 and 2 power 2. So 2 power 2 is 4, 2 power 1 is 2, so 4 plus 2 it is 6. Similarly, when you go for 3, no, we have done with 3. Now here you can see like 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 and 16. So 2 power 0, 2 power 1, so 2 plus 1 it is 3. So when you do the AND operation, both bits need to be 1, then only you will get the answer. So if you find the answer, no, so here I'll put a comment again. Answer is you need to get like 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 bit need to be 1 because both are 1 and 16 bit 0. So 2 power 0, 2 power 1. So your answer is 2. So that's why you're getting 2 here. So 2 power 0, then 2 power 1. 2 power 1 is 2. So your answer is 2. So like this, the binary digits are doing the AND operation. Similarly, if you go for the OR operator, so when you go for OR operator, we'll check. Here I'll put the same thing, but I put a pipeline symbol here for OR. We'll see the answer what it is. So just run it. So you get the 7 answer. Okay. Now if you take the same thing, I'll just put a comment here. Okay. Now here I need to put an OR operation, no? So OR means either bit need to be 1, then it is 1. So here you'll get 1, and here also you'll get 1. Now this is your answer. So 2 power 0, 2 power 1, and 2 power 2. So 2 power 2 is 4, 2 power 1 is 2, and 2 power 0 is 1. 4 plus 2 plus 1. So you get the answer as 7. So like this, you need to work out with the binary numbers. Then you have the exclusive OR. Now when you go for exclusive OR, what is the description we have seen? Sets each bit to 1 if only one of the two bits is 1. So here you can see the same example. I'll take this. 6 exclusive OR, no? You need to put Not this exclusive or. You need to put like this and just execute, and you get 5. Now how you are getting 5? Now here if you take the same thing, now either bit is 1, then only it is 1, right? So here the second bit, if you can see, both are 1. To make it as 0. Okay. So 2 power 0 and 2 power 2. So 2 power 2 is 4. 2 power 0 is 1. So 4 plus 1, 5. So you get the answer as 5. So this is for the exclusive OR. So either bit is 1, then your answer is 1. But here second bit, you can see both are 1, so it becomes 0. Okay. So that is for exclusive OR. Then you go for the negation. Suppose if I take 3, if I go for print of negation of, if I go for negation of 3, now what is your answer here? You can see 3. Okay, I need to get the reverse of that. So you get -4. Okay, that means here when you just check, I'll just copy only this one, and if you go for negation, no, so your answer is becoming, answer is all ones now. 1 2 3 4 5 6 7 8 9 10 11 12 13 14. The last will become 0. Now when you just go for this is leading to -4. Okay, now this is the inversion what you are going to do. So the ones are becoming 0, zeros are becoming ones. Now coming to the left shift 0 fill left shift operator. So here I'm just going for print 3 left shift of 2. Okay, now what is your answer? So you are getting something called 12. Okay, now how you are getting this 12, we'll see. So again I'll take the same, the 3. The simple thing what you can understand here is left shift, right? Left shift of 2. 2 means 2 digits. So you remove this left side 2 digits. Okay. And right side you append 2 digits. Simple. Now you see the answer for this. 2 power 0, 2 power 1, 2 power 2, 2 power 3. 2 power 3 is 8, 2 power 2 is 4. You get 12. 8 plus 4, 12. So this is 2 power 3. This is 2 power 2. 8 plus 4, 12. So your answer is 12. So only from left side you need to remove 2 digits, right? 2 whatever it is, 2 zeros or 2 ones, no problem. But right hand side you need to append only zeros. How many you are removing? That many you are going to assign. Now if I go for right shift, if I go for right shift, print okay, I'll take the same. Okay, if I take the same, okay, 12 will take 12 right shift of 2. Okay, so I'll just, actually this is just copy and I'll paste here. So this was actually 12 and this is 3, right? But now I'm taking this 12. Okay, so you're getting again 3 back. Can you see? So this is 12. Now your simple thing what you need to understand is right shift to 2. So from right side you remove 2 digits. So I'll remove these 2 digits. Okay, I'll copy this and I'm calling this as 3. No, answer is 3. I just remove these 2 digits from here, 1 2, and left hand side you add 2 digits. That's all, over. So you're getting again the same, this one. So whenever I say right shift 2, you remove the 2 digits from the right hand side and add to the left hand side, 2 zeros. When I go for left shift 2, you remove 2 digits from the left and add 2 digits to the right. So this is how we are going to work with the left shift and right shift zero fill operator. So filling zeros. So if suppose I say 12 right shift of 2, I'm removing 2 digits, right? So it could be 1 or 0, no problem, you need to remove. But whenever you're adding at the left hand side, the only zeros to be added. Here also left shift of 2, I'm saying you are removing 2 zeros from the left hand side. Here it could be 1 or zeros, no problem. You need to remove 2 digits. But right hand side, when you're adding the 2 digits, it need to be only zeros. So these are the operators in Python. So I hope I've given some input on the various operators available in Python. So if you like this video, do comment, subscribe, and share it to your friends. Thank you.